So go ahead and sketch this out in your notes real quick. So what I have here is this is the domain to range mapping. Just like the last example that we did. And this is true for any inverse of a function. So basically, over here, let's label these real quick. The domain is the input. The range refers to the output. But if I take the inverse function and I take whatever this output was and now make it the input for my inverse function, then it becomes the original input, which is the output of the inverse. So an easy way to say that is if I plug in -4 and I get -2 for my function of x, if I take that same value, and which is the output of that value, and I plug it into the inverse function, right, I will get the original input value. It just undoes what's being done. So, and I know you guys are trying to copy all this down, so I'll give you a second. But as you're copying it down, I want you to guess what values do you think go in here where the question mark is. In other words, what do you think goes here? What do you think goes here? And then over here we have a trick question, okay? All right. I know some of you guys are finishing up, but if I take a 0, plug it into f, and I get -3, and then I plug in -3 to the f inverse, what do you think I will get here? Any guesses? I plugged in 0, I get -3. I take that -3, plug it into the inverse. Yeah, 0. Okay. Let's do the next one. If I plug in 1 and I get 2, and then I plug in 2 to the inverse, 1. Good. All right, the next one's a tricky one. All right. So if I plug in, the second next one is the tricky one. If I plug in 0, get -3, and if I get -3, what goes here? 0. So the inverse just undoes what's being done. Now, what do you think goes here? 1. Oh, so you guys know it better than you think. Yes, please. So the reason it's called a function is functions have, the easy way to say it is, if you look at the domain to range mapping, there's only one arrow leaving the domain. Now you could have two y values, but notice that there's only one arrow leaving the 4 and one arrow leaving the 1. If you have more than one arrow leaving a value from the domain, it is not a function. The reason we label it a function is we can't reverse if it's not a one-to-one function, right? There is one unique output for every input in a function. There are equations that it's different. I'll give you an example. The square root of x. When you take the square root of a number, you have a positive and negative value, so you have two output values for one input value. Okay? Just ignore that last statement if it confuses you. There are examples. We'll focus on the functions today. All right, do you guys have this written down? Can we go on to the next one? All right, let's go on to the next one and see what we have. This is example 1 from your textbook. So we're just going to go through this process. It says find the function and then find the inverse. Well, they give us the function. So let's go through the process, right? Step 1, substitute y. So the function is f of x is equal to 3x plus 4. So we're going to substitute y for f of x. That's step 1. Step 2, solve for x in terms of y. So we want to get x by itself. We want it to look like x equals some stuff. Okay, what do I need to move? Well, if I want to get x by itself, I need to move the 3 or the 4. Which one's easiest to move, the 3 or the 4? 4. How would you do that? Minus 4. So I'm going to subtract 4 from this side because that's the inverse operation of adding. And whatever I do on one side of the equation, I have to do to the other. 4 minus 4 is 0. 0 plus 3x is 3x. And then over here, I get 4 minus y. They're not like terms, so I can't do anything. I just leave them the way they are. Step 3, switch the x and y. So wherever there is a y, I put an x. Oh, wait, I'm not done yet. We haven't solved. Whoa, whoa. Mr. Adams is really gung-ho. Do I have x by itself? No. I got to move that 3. How do I move the 3? Divide. Right? 3x means 3 times x. The inverse of multiplying is divide. So what's 3 divided by 3? No. 1. What's 1 times x? X. So I'm going to rewrite it over here because I'm running out of space. X. And then we just leave everything else the same. Y minus 4 over 3. Step 3 now. So this is step 2 completed. Step 3 is I'm going to flip-flop the y and the x. So there's an x here, put a y. There's a y here, put an x. That's step 3. Last step, step 4, I'm going to replace the y with the f inverse notation. Inverse of f is equal to x minus 4 all over 3. That's step 4. So that's the algebra part. So I created another equation that will reverse the work that was done by f. Does that make sense? Okay. Notice it's a little more complex than the last one. But if you think about it, we're doing order of operations backwards, just undoing the math that was done. So sketch this graph. Okay. To the best of your ability. One thing that I want to point out is that, I'll make it a little bigger. Notice that it reflects across y equals x. See that little green dotted line? Notice that this blue line is the mirror image of this thing if the mirror was this little green line. Okay? Notice that. I do want to point out a couple of points. You don't have to label every point, but this point right here, what's the coordinates for that? 0, 4? Yeah? Be sure to write that down. What's the coordinates for this? 4, 0. What do you notice about the x and y values between f and f inverse? Yeah, they switch. They flip-flop. Right? They flip-flop. Okay? That's no accident. Do you guys want to try and graph this on your calculator just to see? Let's see. Oh, some of you are still writing down. So, I'll wait a second for everybody. All right, this is how you put it in your calculator. Go to y equals. Let me move my face out of the way. Type in 3x plus 4 for y1. Actually, you know what? Let's make it match the other graph. I think our f function was blue, so let's change that color to blue. I'm going to do navy. And then let's do the other one to red, right? Okay. Now leave the y equals x green. Okay. But what was that inverse function again? Remember to put the numerator in parentheses. So I'm going to do x. Oops, that's not x. X minus 4 divided by 3, right? Is that what my inverse function was? X minus 4 divided by 3? Yeah. So I'll leave that up there on the screen. So what I've done is I've graphed f inverse, that's my y2. I've graphed f as y1, and then my line of symmetry is y3. Okay? Go ahead and enter or hit graph. Notice that blue line is the mirror image of the red line across if the mirror was the green line. For inverse functions, if you've done all the algebra right, it will always look that way. If it doesn't, you made an algebraic mistake somewhere. Okay? Now I'm going to make a copy of this and put it in the notes, but you guys only have to sketch it in your notes one time. I just want to verify that we did it by hand, and it looks just like the way the book had it. Okay? So I'll put that over here somewhere. All right. Any questions on that? How do you feel now after we've done the second one? Right? Thumbs up if you kind of get it better. I like this. It went from here to like, that's good. We just need to do a few more examples. Okay.